A kangaroo laid out 3 sticks like this to make a shape. It is not allowed to break or bend. So the kangaroo cannot break the stick or bend it. Which shape could the kangaroo make? Alright, so let me draw it. This is 1 stick, 2 stick, 3 stick. As you can see, we need another stick here. We need another stick to make this one. So this I cannot make. Similarly, if I draw it out here, 1 stick, 2 stick, 3 stick, I still need another stick, this one. Same way, 1 stick, 2 stick, 3 stick, so I still need another stick here. Same way, 1 stick, 2 stick, 3 stick, I need one more stick to make this. Here, 1 stick, 2 stick, 3 stick. So I can make this figure. Then E is the correct choice. The picture shows 2 mushrooms. What is the difference between their heights? Okay, so there are 2 mushrooms here, one taller one shorter one. And as you can see, let's count the divisions. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 divisions. So each division is 1. Okay, so what is the difference between their heights? So this point is 12, so this is 11. The taller mushroom is 11 units high. The shorter one is 1, 2, 3, 4, 5, 6. So this is 6 units high. So 11 minus 6 is 5. Then B is the correct choice. All right. Which of the paths shown in the pictures is the longest? So we can simply count the length. As you can see, this is a square grid. So let's count each unit as 1. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 15 units. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Similarly, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we want the longest one. Then 15 is the longest, then A is the correct choice. 4 identical pieces of paper are placed at shown. Michael wants to punch a hole that goes through all 4 pieces. At which point should Michael punch the hole? Alright, so let's take a look at each point. As you can see, A, let me first number the sheets. This is 1, 2, 3, and let me call this 4. As you can see, A does not go through sheet 1. So A is not the correct choice. How about B? B, as you can see, B goes through sheet 2 and 4, but not 3 and 1. So B also cannot be the correct choice. C goes through sheet 1, 2, and 3, but not 4. So C also cannot be the correct choice. If I look at point D here, actually let me let me just draw the, so it is more clear. This is sheet 4. Let me draw similarly. Let me also draw sheet 3 and then sheet 2. Right? So if we look at point D, D is going through 1, 2, 3, and 4, all the points. So D seems like a correct choice. Let's double check E. E, as we can see, E is not going through sheet 3, right? E is going through 1, 2, and 4, but not 3. So E is not the correct choice, then D is the correct choice. Ella puts on this t-shirt and stands in front of a mirror. Which of these images does she see in the mirror? Okay, so this is a t-shirt written 2021 or 2021 on it, and then standing in front of a mirror. So which image I see? All right, so this problem is slightly tricky to explain. So let me write 2021. Put it on a t-shirt. This is a t-shirt actually, and then put it on me. Okay, so this is me wearing the t-shirt, written 2021 on it, and then this is the mirror. Okay, so mirror is like this. I'm standing in front of the mirror, but I have drawn myself slightly tilted so that we can see it, right? So this is me. This is me. So when we write, actually I have written it on a piece of paper. We write from left to right. 2021. This is left to right. Okay, but when I put it on a t-shirt, the 2 is going to be on the right hand side. So this is my right hand, right? 2021. 2 is on the right hand side. All right. So this is my right hand, then this is my right hand, this is my left hand. Okay, and I'm standing in front of the mirror. So let me start drawing the reflection. Let me start with 1. Actually, let me make the proper shape of 1, because this is going to be important. Okay, so let me start with 1, because 1 has straight lines and it will be slightly easier to draw. And when you draw a reflection, the way basically we draw a reflection is each point has to be equidistant from the mirror, right? So for example, let's take this point here, right? Let's say that point. So this distance has to be same as this distance. That's how I will draw the reflections, right? Now if I draw this point here, then I can just join it. So that is this point. So this is this line. Okay, now I will try to draw the base of 1. This point is a little bit closer to the mirror, so that point is going to be here. This point is a little bit farther away, that is going to be farther away, and then I just join it. So this is the base of 1. Okay, now let's talk about this point, right? So this point is the same. This point is the same. How about this point? So that point is a little bit farther away from the mirror, right? So if I draw a line, so this point is going to be a little bit farther away from the mirror, and then I just join this two line. So this is how my 1 is going to look like. So this is me, this is the reflection. All right. Okay. From here itself, we can see that, some choices do not match, but let me draw a few more of the numbers. How about 2 now? So let me first try to draw the base of 2, because there's a straight line, so it is easy. So that is, and see, 2 is a little bit farther away from the mirror than 1, right? 2 is farther away from the mirror than 1. So then this 2 is going to be farther away here also. Okay, so that is the base, that is this base here, and then you can see this shape is goes towards the mirror and then comes out. So here goes towards the mirror and comes out, right? So that is going to be the 2. 0 is going to be easy, it's just a circle, so it will stay the same. It basically just reflects. And then 2 again, so I'll start with the base, and this 2 is the farthest, so here also it will be the farthest from the mirror, and I'll start from the the farther end of that 2, so here, and then similar like this 2, it curves towards the mirror and then out, so it will curve towards the mirror and then out. Okay, so if we can see, compare, so this is the reflection. So I'm standing in front of the mirror, right, and written 2021 on my t-shirt, and when I look myself in the mirror, this is how I'm going to see. And if we compare this one, we can see that 1202, so this is how it is going to look like, right? So this starts with 2, so this is definitely not the correct choice. Starts with 0 is definitely not the correct choice. 1, but 1 is not looking, 1 is not looking the same. It's not the correct choice. here also 1 doesn't look like that. A is the only one that matches with the reflection. So A is then the correct choice. This problem is something you can try it yourself at home. It's something you should try actually, because it gives a good experience, and I have done that myself. So I took a sheet of paper, like I showed you earlier. I took a piece of paper, wrote 2021 on it, stuck it on myself, and then first took a selfie. So this is a selfie. So this is how, if you look at me, this is how you will see 2021 written on the piece of paper. And then go to your bathroom and stand in front of the mirror, and then look at your reflection. And this is the reflection. You can see my phone also in the reflection. And as you can see, the reflection looks like this. So again, A is the correct choice, and you should definitely try it yourself at home to get the first-hand experience. The pink tower is taller than the red tower but shorter than the green tower. Now the silver tower is taller than the green tower. Which tower is the tallest? So we want to find the tallest tower. So the towers are colored differently, so I could use different colors for each tower, but sometimes it is nice to use just one color, because in the real test you'll have only one color pencil. So I'll just try to manage with one color. So this is the base. This is the base, and I'm going to draw the tower on it. One thing you can see is I could write the name pink, red, but we can see that they all start with a different letter: P, R, G, and then S. So I'll just write the first letter, so that way it is also faster. So pink tower. So let me draw this tower and call this pink. P for pink is taller than the red tower. So pink is taller than red. So this is my red. So the pink is taller than red. Okay. So but shorter than green tower. But the pink is shorter than green. That means green is even taller, right? So this is green, right? So the pink is shorter than green. Okay. Now the silver tower is taller than green tower. The silver tower is even taller than green tower. So S for silver is even taller than the green tower, right? Which tower is the tallest? As you can clearly see here, silver is the tallest tower. Then D is the correct choice. These children are standing in a line. Some are facing forwards and some are facing backwards. How many children are holding another child's hand with their right hand? Okay. Now, one thing to notice is the kids, they are inside, they are using both their hands. So we don't need to check them. We know that this kid, this kid, this kid, this kid, and this kid, 1, 2, 3, 4, 5 kids, they are using both their hands, so they must be using their right hand also. So we need to only check this kid and this kid. Okay, so this kid is facing forward and holding this hand, so it is not using the right hand, it is only using the left hand. Okay, so this kid on the other hand is standing here and holding on this hand, so it is using the right hand. So then she is also using her right hand. So 1, 2, 3, 4, 5, 6. E is the correct choice. She is the only one who is not using her right hand. In the Kangaroo constellation, all stars have numbers greater than 3, and their sum is 20, which is the Kangaroo constellation. Okay, so all the numbers have to be greater than 3, so we can clearly see that this is 1 not greater than 3, so D cannot be the correct choice. Again, 2 is not greater than 3, so E cannot be the correct choice. 2 here is not greater than 3, so C cannot be the correct choice. So the remaining are these two, A and B. Now, if we sum them up, I can see that 7 plus 5 is 12, plus 4 is 16, plus 6 is 22, but the sum has to be 20. This is 8 plus 5 is 13 plus 7 is 20. So this adds up to 20. This adds up to 22. So this cannot be the correct choice. B is the correct choice. Edmund cuts a ribbon as shown in the picture. How many pieces of the ribbons did he finish with? So this is the ribbon and it makes a cut. So we can simply trace out and count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then D is the correct choice. Actually, there is an easier approach to this problem. If you think about it, let's say if I take a piece of ribbon, if I make a one cut, there will be two pieces. If I make two cuts, there will be three pieces. So number of cuts, number of pieces. So if I make one cut, there are two pieces. If I make two cuts, there are three pieces. If I make three cuts, there will be 1, 2, 3, 4 pieces. If I make three cuts, there will be 4 pieces. So if there are n number of cuts, there will be n plus 1 number of pieces. So how many ever cuts we make, we end up with one more than that number of pieces. So here in this case we can count how many cuts are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 cuts. So we must end up with 12 pieces. Then again, D is the correct choice. And just to make it clear, the ribbon doesn't have to be straight. The ribbon can be any way. So if you make 3 cuts, there will be always 4 pieces. 1, 2, 3, 4. If you make 5 cuts, there will be 6 pieces. If you make 11 cuts, there will be 12 pieces, right? So this is always true. The ribbon doesn't have to be straight. It can be curved. It does not matter. One more thing. If the ribbon was a loop, not a open-ended, but it is a loop, then if you make one cut, you will end up with one piece. If you make 2 cuts, you will end up with 2 pieces. So if it was a closed ribbon, not open-ended ribbon, it was a closed ribbon. If you make n cuts, you will end up with n pieces. Since this is an open ribbon, we can see that this is an open ribbon. If you make 11 cuts, there will be 12 pieces. Rose, the cat, walks along the wall. She starts at point B. So this is point B. And follows the direction of the arrows shown in the picture. The cat walks a total of 20 meters. Where does she end up? We can simply start from B and walk and keep adding the number. So from B to C is 4, plus 1 is 5, plus 5 is 10, plus 2 is 12, plus 3 is 13, plus 4 is 17, 18. Did I mess it up? Sorry. Rose, the cat, walks along the wall. She starts at point B. So she starts at this point B. And then follows the direction of the arrows. The arrows are given. The cat walks a total of 20 meters. Where does she end up? So we can simply start at B and start walking. So this is 4 plus 1. So 4 plus 1 is 5. And then D to E is another 5. So 10. We are at E now. E to A is plus 2 is 12. So 12 we are at A. And then A to B is another 3. So this is 15. We are at B now. B to C is 4. So plus 4 is 19. And that brings us to C. From C to D is 1. So this is 20 and we end up at D, right? Then D is the correct choice. Julie and Angela played kangball, a ball game. Each goal in their game scores 2 points. Julie scored 5 goals and Angela scored 9 goals. How many more points than Julie did Angela score? All right. So Julie scored 5 goals and each goal is 2 points. So 5 times 2 is 10 points. Okay, so Julie scored 5 goals and each goal is 2 points. So 5 times 2 is 10 points Julie gets. Angela scored 9 goals and each goal is 2 points. So that is 9 times 2 is 18 points. So 18 points for Angela. And we need to find out how many more points than Julie did Angela score. So Angela scored 18, right? And Julie scored 10, so minus 10, so 8. That means Angela scored 8 more points than Julie, and then C is the correct choice. Julia has 2 pots with flowers shown here. She keeps the flowers exactly where they are. She buys more flowers and puts them in the pots. After that, each pot has same number of each type of flowers. So same number of each type of flowers. What is the smallest number of flowers she needs to buy? All right, so she cannot change flowers from one pot to the other. She needs to buy more flower so that this condition is met. Okay, so let's check each flower type. First, the black ones. There are 2 here, there are 3 here, so I need one more of black. Okay, there are 4 gray here, 1 2 3 and 4 gray. There is only 1 gray here, so for gray I need to put 3 more gray in this bucket. Okay, there are 2 white flowers here, there are 4 here, so I need 2 more white flowers to put in this bucket. So I need total of 1 plus 3 plus 2 is equal to 3 plus 1 is 4 plus 2 is 6, right? So I need at a minimum 6 more flowers to buy, so that I put 3 gray in this, 1 black in this, 2 white in this bucket, so that this condition is met. So the correct answer is 6C. Tom encodes words using the board shown. So this is the board for encoding. For example, the word pizza has the code this. What word did Tom encode as this? All right, so let's verify how the encoding works. For example, A2 is P, so this is P. A4 is I. C1 C and 1 is G. C1 is same, so this is again G. And then B2 is B, 2 is A. So we can verify that pizza is encoded as this. All right, so now let's check what word this encoding means. So B3, B and 3 is M. Then B2, let me see, B2, B and 2 is A. C4, C4 is T. D2, D and 2 is H. All right, so this then corresponds to math. Correct choice is E. Which figure can be made from these 2 pieces shown? Which figure can be made? All right, so we have 2 pieces. This is one, this is another one, and when we combine it, which of these we can make? As you can see, this goes here, right? So that it's a complete square. So let me try to imagine flipping it and putting it here, and then try to draw that. Okay, So as you can see, if I flip it and put, the circle will go here, right? The diamond will go here. This will be plus, plus. This will be a circle, plus, diamond, and a plus. So this is how it is going to look like when I, turn it and put it in that. Okay, so let's see which one matches. Okay, now the different shapes and colors, right, can make you actually feel confused and dizzy. So I think there is a nice way to do that. Let me number each column. You can number each column and check one at a time, or you can also number each row. Either way, I'll number the columns. Let me call column 1, 2, 3, 4. Okay, so I need to find a column that is a diamond, diamond, circle, and plus. So let me see if this one will match. Diamond, diamond, circle, and plus. So this can be column 1. And next to that has to be a circle, circle, plus, and diamond. Circle, circle, plus, and diamond. So this can be column 2. Then plus, diamond, plus, 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 diamond, plus, plus. So this can be my column 3. And then circle, diamond, plus, circle. Circle, diamond, plus, circle. All right. So this seems like a possibility. Okay. Now let me check this. So let me try to match first the column 1. So diamond, diamond, plus, circle, diamond. I can't even see a diamond, diamond together. So this is not going to work. Now let's try this. See, again, diamond, diamond, circle, plus. There is one diamond, diamond, circle, plus. So this doesn't even match. So C is not going to work. Again, let's start with column 1. Diamond, diamond, circle, plus. Diamond, diamond, circle, plus. So this can be my column 1. Again, so this I cannot have column 1. I could have started from here, but again, the diamond, diamond has to be on the edge, right? So I have to have this as 1. And then I have next to that should be circle, circle, plus diamond. So circle, circle, plus diamond. So that is fine. And then plus diamond, plus, plus, plus diamond. So this is not matching. So this is not going to work either. Check the last one. So diamond, diamond, circle, plus, diamond, diamond, circle, plus. So this is not matching. Again, I have to start here because the diamond, diamond has to be on the edge. I cannot start from here. So again, E is not matching. So only A is the correct choice. The picture shows 5 houses of 5 friends and their school. The school is the largest building. All right, so this is the school. It's also written school. To go to school, Doris and Ali walk past Leo's house. Eva walks past Chole's house, which is Eva's house. All right, so 2 friends, Doris and Ali, they walk past Leo's house. So 2 walk past Leo's house. So this must be Leo. L, I'll write L. And one of this is Doris, one of this is Ali. Either Doris, Ali, or Ali's Dory. Doesn't matter, right? Now, Eva walks past Chole's house. There's one friend, so this must be Eva walks past Chole. This must be Chole's house, which is Eva's house. So Eva must be this one then. B is the correct choice. The kangaroo had 2 branches for lunch. Each branch had 10 leaves. The kangaroo ate some leaves from one branch. Then from the second branch, it ate as many leaves as were left on the first branch. Okay? How many leaves in total were left on the 2 branches? Okay? Okay, so let me make a small table. Call it branch 1, branch 2. Okay? Suppose this is how many leaves the kangaroo ate, and this is remaining. Suppose it ate, we can pick a number between 1 and 10, let's say 3. It ate 3, then branch 1, 7 will be remaining, right? So because 3 plus 7 is 10 and there are 10 leaves on each branch. On branch 2, it says it ate as many leaves as were left on the first branch. There are 7 left on the first branch, so the kangaroo must eat 7 from the second branch, right? Because that's what it says here. Now, if it eats 7, there will be 3 remaining, right? Now, it says how many leaves in total were left on the 2 branches. So the remaining is 7 plus 3 is 10. Okay. Now this will work with any number you pick here, right? You can definitely try it out and see that no matter what number you pick between 1 and 10, you will always end up with 10 remaining leaves. Then D is the correct choice. All right. If you're familiar with algebra, you can also do it in a slightly more general way. So let me show how to do that. So let me call branch 1, branch 2, and this is how many 8, and this is how many remaining. Let's suppose the kangaroo ate n leaves from the branch 1. There were, to start with, there were 10, right? There are 10 leaves. So the remaining will be 10 minus n. Okay. Now, from the second, it ate as many leaves as there were left on the first branch. How many were left on the first branch? 10 minus n. So it must eat 10 minus n from the second branch. Now, how many will be remaining on the second branch? So there are total of 10 minus how many ever it ate? And it ate 10 minus n and 10 minus n. Note that this 10 minus n has to be in parentheses, right? Because this is the amount it ate. So we have to subtract the whole thing from 10. This is 10 minus 10, right? This negative will be positive. So this will be plus n. 10 will cancel out. This will be n, right? So in the second branch, n leaves are remaining. Now, how many total are remaining? So that is this plus this. So 10 minus n plus n. So 10 minus n plus n. So that is the remaining from the first branch is 10 minus n. Remaining from the second branch is n, right? So this together, again n cancels out 10. So as you can see, no matter what the value of n is, you will always end up with 10. So then D is again the correct choice. Mara built the square by using 4 of the following 5 shapes. Okay, 4 of the following 5 shapes. Which shape was not used? Okay, so there are 5 shapes, 1, 2, 3, 4, 5, and using 4 of this square was built. Okay, so which one of this was not used? All right, so if you actually look at individual shapes, you can find all the individual shapes in this, right? So we cannot rely on that okay, which shape is not available here, right? We have to look beyond that. Note that there are 1, 2, 3, 4 times 4. So there are total 4 times 4 is equal to 16 of the smaller square that needs to be used, right? So total of 16 smaller squares we need. But if you see here, so there is 4 square here, there is again 4 square here, there is 3 here, this is 4 here, this is 5 here, right? So we need to be able to add 4 of these numbers to get to 16. Then you realize that we must include 3 and 5, because if let's say I do not include 3, right? So then 4 plus 4 plus 4 plus 5 cannot get me to 16. Similarly, if I exclude 5, 4 plus 4 plus 3 plus 4 cannot get me to 16. So this 3 and 5 must be included. So this cannot be the choice. Okay, the rest we need to figure out. Let me first put this in here. So there's arrow, 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 circle, circle. Let me find that pattern. So that is this pattern here. Arrow, 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 circle, circle. Okay, so that is E, and then star 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 and a circle. So that will be this pattern here. So this is already taken. Now we need to find the remaining, right? The remaining should be made using A, B, and D, but one will be not used. So let me see. Let me see which one will be not used. We can see that I can have star, 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 and diamond. So I can use A. So this is again A. Let me write it down so that it's clear. So this was C. I made this pattern using C, and then I made this pattern using E. Okay, so I'm using A, C, and E so far, and the remaining pattern that I have to make is diamond, 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 and a circle, right? And I can clearly see that that fits very well with B. Diamond, 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 in a circle. So this one here is going to be my B, right? So the again B. So I'm using A, B, C, and E. A, B, C, and E. Then D is the correct choice. So D is the one that will not be used. Every time the witch has 3 apples, she turns them into 1 banana. Okay, 3 apples into 1 banana. 3 apples into 1 banana. Every time she has 3 bananas, she turns them into 1 apple. So 3 bananas into 1 apple. What will she finish if she starts with 4 apples and 5 bananas? Okay, she is starting with 4 apples and 5 bananas. It is difficult to keep drawing apples and bananas, so I'm just going to write A for apple and B for banana. So I have 4 apples, 1, 2, 3, 4, and 5 bananas. 1, 2, 3, 4, 5. Okay, so every time I have 3 apples, I turn them into a banana. So this 3 apple next time will be a banana, right? Apple is remaining. I have also 3 bananas. So this 3 banana will turn into an apple, right? And then I have 2 bananas. Okay. Okay. Next, I can see that there are 3 bananas. So these 3 bananas will turn into an apple. This apple is remaining. This apple is remaining. Now I have 3 apples. So now these 3 apples are going to turn into a banana, right? So what will be left is a banana. Correct choice is A. The cards 2, 3, 4, 5, 6 are placed into 2 boxes. The sums of the numbers in each box are the same. Which number must be in the box with the number 4? All right, so we have the numbers 2, 3, 4, 5, 6. We have to put them in 2 boxes in such a way that the sum in each box is the same. Okay, so let me first find the total sum. 2 plus 3 plus 4 plus 5 plus 6, and this is going to be 2 plus 3 is 5 plus 5 is 10, and then 6 plus 4 is another 10. So I have the sum as 20. Okay, so I have 2 boxes. So let's say this is box 1. Box 1. This is box 2. The sum here has to be 10. The sum here also has to be 10. All right. So let me start with 6, because 6 is the biggest number, and then I can see how much I need to make it 10. So if I start with 6, I see that I need the 4, right? There is no other way I can make 10. If I take 6, let's say with 2, that is 8, nothing else I can choose will get me to 10. Similarly, you can also try with other numbers. So then 6 must go with 4. So then 6 must go with 4, and then remaining 2 plus 3 plus 5 must go together. This is the only way I can have 10 here and 10 here. Then which number must be in the box with the number 4? Then D is the correct choice, because 6 has to be with 4. The picture beside shows 2 cogs, each with a black tooth. There will be, where will the black teeth B after the small cog has made one full turn. The small, this is the smaller one, and there's the black tooth here. So after it has to make one full turn, and the arrow shows which way it is turning, right? So after it turns by one teeth, let me see for how many teeth it will turn to be at the same place. So it has 1, 2, 3, 4, 5, 6, 7, 8, right? It will turn by 8 teeth to be at the same place. And when it turns by one tooth, this is going to go by one, right? So let me count 1, 2, 3, 4, 5, 6, 7, 8. So the black teeth is going to be somewhere here when this has turned one full turn, right? So this matches with the choice C. Three girls and two boys were dancing. They danced in pairs so that each girl danced with each boy for exactly 1 minute. At any time, there was only one pair on the dance floor. For how many minutes did they dance? Okay, there are three girls, one, two, three, and there are two boys. B for boy, one and two. So each girl danced with a boy for exactly 1 minute, right? So the girl one will dance with boy one 1 minute, and then boy two 1 minute, right? And for exactly 1 minute. And at any time there was only one pair on the dance floor, right? So this is 1 minute m per minute. This is another 1 minute, right? So first girl will dance for 2 minutes in total. Similarly, the girl two will dance with boy one and boy two. So this will be another 2 minutes. Similarly, girl three will dance with boy one and boy two, each for 1 minute. So this is another 2 minutes, right? So this is total of 1, 2, 3, 4, 5, 6. Total of 6 minutes, right? So for how many minutes did they dance? They must dance for a total of 6 minutes. B is the correct choice. Each participant in a cooking contest baked one tray of cookies like the one shown. So, okay, this is one tray of cookie. What is the smallest number of trays of cookies needed to make the following plate? The smallest number of trays. So each tray looks exactly the same. And what is the minimum number of such tray I need to make this plate, right? So we can check each shape. So I need this shape. Whatever this shape is called, I need three of this, right? Each tray has only two, so I need a minimum of two of this tray, right? If I consider this shape, like two trays will have four of these, and I can pick three. Okay, let me take another shape. So this is the star shape. I need four of this, one, two, three, and four, and each tray has three. So if I have two trays, then I'll have six of these, and I can pick four of these. So that's good. Okay, now let me check the moon. Moon, I need one, two, and three, but each tray has only one. So two is not going to work. I need at least three, then I can pick one from each, and then I have three, this moon shape. Okay, so two is not going to work. I need at least three. Now let's check the other shapes. I can check the heart shape. I have one and two of those, and in one plate I already have two, so I'm good with that. Now I can check the triangle shape, that is remaining is triangle, and each tray has three. I need only two, so I have more than plenty in three trays, so I need a minimum of three trays. Then C is the correct choice. Kanji, it's only apples on Mondays, Wednesday, and Friday. Okay, apples on Monday, Wednesday, and Friday. Okay, on Tuesdays and Thursday, he eats only mangoes. On Tuesdays and Thursday, he eats only mangoes. Okay, he eats either two apples or three mangoes a day. On Saturday, Sunday, he eats nothing. How many pieces of fruit does Kanji eat in 2 weeks? Seems like a very picky Kanji, but okay, let me write down the days of the week. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So this is days. Okay. Fruits. On Monday, Wednesday, and Friday, he eats apple. A for apple. Monday, Wednesday, and Friday, he eats only apples. On Tuesdays and Thursdays, Tuesday and Thursday, he eats only mangoes. Mangoes. But he eats either 2 apples, not one, 2 apples, or 3 mangoes each day. So in 1 week, and Saturday, Sunday, anyway, he doesn't eat anything. So this is total of how many? 2 plus 3 is 5. This is another 5, 10 plus 2 is 12 fruits in 1 week. So in 2 weeks, then times 2 is 24. 12 times 2 is 24. Then it's 24 fruits in 2 weeks. Stan has 5 toys, a ball, set of blocks, a game, puzzle, and a color. He puts each toy on a different shelf of the bookcase. So this is a bookcase, and he's going to put different toys on different shelves. The ball is higher than the blocks. Okay, ball is higher than the blocks. So let me start writing it down. Ball is higher than the block, so block has to go below. Okay, and lower than the car. So the ball is lower than the car, so the car has to go on the top. Okay, and lower than the car. Okay, now the game is directly above the ball. Okay, the game is directly above the ball, so game has to go here. Then game is directly above the ball. Okay, on which shelf can the puzzle not be placed? Okay, so the puzzle, in which of the shelves the puzzle cannot be placed? All right, so there are 5 shelves, right? So the puzzle can go here, here. It cannot go between ball and game because game is right on top of the ball, but the puzzle can go here and here. So as you can see, I can put the puzzle on 1. It's fine, right? The puzzle can be 1, 2, 3, 4, and 5. So A cannot be the correct choice. I can also put it on 2 because I can first put the block and then the puzzle. So 1, 2, 3, 4, 5. So then B is also not the correct choice. Can I put it on 3? After this, first cell, second cell, after this, if I don't put it on this 2, it has to be 1, 2, 3. It has to be on the 4th cell, right? Because I cannot put it between ball and the game. So I cannot put it on the 3, but I can put it on the 4, and of course I can put it on the 5 too, right? So 4 and 5 are also not possible. Then C is the only shelf I cannot put the puzzle.